Okay, welcome back. In this video we're going to be doing number 93 on the homework. This deals with a pizza shop and then kind of an application of inverse functions. So the situation we're dealing with is a pizza shop that charges $16 for a large pizza. So that's the base price, and then it charges $150 now, $1.50 for each individual topping that you add to that. So if you got a large pizza with one extra topping, it would be $17.50, right? So every time you add a topping, you add $1.50 to the total price. Okay. And so our first part of this question for 93, there's I think ABC parts, right? A asks us to find a function that models the price of the pizza with n toppings. So let's say we have n toppings. We want to find a function. It will be in the variable n, so I'll say f of n. That models the price of this pizza. So n can be anything. It could be 3, 5, 7, as many toppings as you want, basically. We want to find a function that you just plug n into and you get the price of the pizza. Okay? So how do we find the price of the pizza? Well, if you kind of think for a particular value of n, how you get the price of the pizza is you start with the $16. That's just a flat price, right? You start with 16, and then for every topping there's $1.50 more added to it. So if you had 3 toppings, for instance, you would add 3 times $1.50 to the 16 to get your total price. So this would be with 3 toppings. With n toppings, how are we going to get our price of the pizza? It would be, you start with the 16, like we did, right? And then we do as many $1.50s as there are toppings. So n times 150, or 1.5 if you want to write it like that, okay? So this number is the number of toppings, right? So any number of toppings you plug in there, you times it by $1.50, and then add that to 16. That gives you the total price of your pizza. Okay? So that would be part A. That's your function here. And I'm maybe just going to rewrite it so that it looks a little bit more familiar. It would be 16 plus 1.5 n, okay, because 150 is the same as 1.5, and I just changed the order because typically we don't write x times a number, we write the number times x, but either's fine. This is just maybe a little bit nicer way of writing it. Okay, so that's the function that gives us the price for the pizza depending on the number of toppings. So let's do B now. B is find the inverse of the function f. What does f inverse represent? So we're looking for the inverse. F inverse of maybe x. It doesn't really matter. Okay, we're trying to find that inverse function. Okay, so remember, to find an inverse function, this one doesn't have x and y in it, but this is kind of like your x. The n is the x in this case. So we're going to start here. I'm going to loop up and continue over here. Oh, like that. Okay. Remember, to find the inverse, you start by replacing the function notation with y. It doesn't really matter what variables you use, but okay. I'm just gonna write it like that, and then remember x and y switch. this is like the x in this equation. You really could use the variable x if you want to. It doesn't matter. But I'm just going to keep it n because that's what they told us to do. Okay, switch those up. And then we switch those variables, and then we solve for y. Okay, so we're going to subtract 16 from both sides. Okay, and so we get n minus 16 is equal to 1.5y. And then how are we going to get y alone? We're going to need to divide by that 1.5. So we'll do that on both sides actually, right? We can't just do it to one side. So we get y is equal to n minus 16 over 1.5. So I'm going to use the variable x for the inverse. It doesn't really matter, just so that we don't get confused here. This is going to be x minus 16 over 1.5. Okay, that is your inverse function. Okay. Now, there might be you could probably write this a different way if you wanted to with fractions, but this is okay for what we're doing here. Okay, last thing, there is a part C here. Oh, I forgot. On part B, it asks us, what does this inverse mean? Okay. Well, remember, with the original function, you plugged in the number of toppings, you got out the price, okay? So this one, you're going to be plugging in, it flips those, right? It switches the price and the number of toppings. So this out here, the thing that you get out from the inverse function is not the price, it's actually the number of toppings. Okay. And then x is the price. Okay. So you plug in the price and you get out the number of toppings. Kind of like with this one, we plugged in the number of toppings, got out the price. So that just switches for the inverse function. We plug in the price, get out the number of toppings. So that's what this inverse function is doing. Okay, I'm going to remove this board right here, and we'll keep going. Actually, I'm just going to erase it. Okay. There we go. Fresh start here. So C, the very last part of this question is, if a pizza costs $25, how many toppings does it have? Okay, so C, the pizza cost is $25 total. We just want to know what's the how many toppings does it have? Okay, so which function do we want to use? We could use the original function that we came up with, but actually the one that we'll want to use is the inverse, because you plug the price or the cost into it and you get out the number of toppings. So that's what we're looking for, is the number of toppings. So I'm just going to be doing the inverse function at 25, and that is going to give us the number of toppings. Okay, so we just plug in 25 for x here. Okay, so we get 25 minus 16, I think is 9, divided by 1.5. I don't remember what that is off the top of my head. Let me grab my calculator. I think it's probably 8 or something. I don't know. Don't pay attention to me trying to do math in my head. Okay, it's 6. So that's 6. So if you get 6 toppings, okay, that's going to give you the cost of 25. So really the inverse function is just kind of turning the equation around so that you get kind of backwards of what you did before. So that's number 93 on the homework. Hopefully that helps. And that is it for 2.8. So you finished. Good work, and I'll see you guys in class or online again soon.